All right, so get this. We're talking about a planet, right? But it's not just any planet.
No, not just any planet.
This one's outside of our solar system.
An exoplanet.
Yeah, an
Yeah.
exoplanet. And get this, it's right in our cosmic backyard.
Absolutely.
Like if our sun was, say, a basketball,
Okay.
this star would be a golf ball a few football fields over.
Close.
Close.
In cosmic terms, yeah, really close. And what's even more exciting is we're not just talking about, blurry data points anymore.
Right.
We're getting to actually see this planet thanks to the James Webb Space Telescope.
Oh, the James Webb. Okay, so we're not talking about relying on shadows and wobbles to guess what's what. We're talking like actual images of Proxima b.
Images.
That's amazing. What kind of details can we even see with this new direct imaging?
Well, we can analyze the light reflecting off its atmosphere,
Okay.
which can tell us things like its temperature,
Okay, yeah.
what its air is made of.
Yeah.
We're even getting hints about potential clouds and weather patterns.
Hold on. Clouds and weather on a planet light years away. That's wild.
It is.
And speaking of what's in the air over there, the JWST found something kind of incredible. A water vapor.
Yeah.
It's like the holy grail of exoplanet hunting, right?
It's a big deal. Now, let's not jump to conclusions.
Right.
It doesn't mean we found an alien ocean or anything.
Right.
But on Earth, wherever we find water, we tend to find some form of life.
Right. Makes you wonder.
It really makes you wonder what kind of environments might exist on a planet with water vapor in its atmosphere.
Yeah.
Could there be rain,
Yeah.
clouds?
Okay, so maybe not time for alien swimsuits just yet,
Right.
but definitely something to think about.
Definitely.
And here's another clue in this whole cosmic detective story.
Okay.
Proxima b's atmosphere, it's not just any atmosphere. It's way denser than Earth's. We're talking like 2 to 3 times denser.
At least.
Can you imagine the pressure?
It's true. And it gets even more interesting when you consider what this thick atmosphere is made of.
Okay.
It's not just like our air here on Earth. Early data suggest a high concentration of carbon dioxide, which could have a significant impact on the planet's climate and potential for life as we know it.
So this dense CO2-rich air, is that a good thing or a bad thing for life? Like, on one hand, it seems like it would make for some seriously heavy breathing, but could it also be a shield against something?
You're right on the money with that shield idea.
Yeah.
A thick atmosphere like that could act as a protective barrier against Proxima Centauri's intense radiation and solar winds, which are a constant concern.
Oh, okay.
Think of it like planetary sunblock.
Planetary sunblock, I like it. But before we get too comfy under that blanket of protection, our sources mentioned something about Proxima Centauri being a bit temperamental, like prone to throwing massive stellar tantrums.
Ah, yes, the flares.
The what?
The flares.
Okay.
That's where things get really interesting
Yeah.
and a little dicey for the habitability of Proxima b.
Dicey in what way? Lay it on me. So about those stellar tantrums, are we talking about like your average solar flare here or something a little bit more intense?
Yeah, it's not your average solar flare, that's for sure.
Yep.
Proxima Centauri is a red dwarf star, which means it's much smaller and cooler than our sun. But don't let that fool you. These stars are known for their powerful flares, eruptions of energy that can be thousands of times more intense than anything our sun throws at us.
Thousands of times. Okay, that's not good. What would one of these super flares even do to a planet like Proxima b, especially with that thick atmosphere we were just talking about?
Well, that's the million-dollar question, isn't it?
Right.
We know that stellar flares release massive amounts of radiation.
Right.
On Earth, our magnetic field protects us from the worst of the sun's outbursts.
Right. Right.
But on Proxima b, with its closer proximity to its star and a potentially weaker magnetic field, these flares could be stripping away its atmosphere over time.
So all that planetary sunblock we were excited about could just get blasted away.
It's possible.
That's rough. And what about like anything living on the surface? Would these super flares be like a constant threat to life?
It wouldn't exactly be a picnic, that's for sure. Imagine living under a sky that could unleash a sunburn-inducing blast of radiation at any moment.
Yikes.
Yeah.
Yeah.
Well, some scientists believe that life could find a way to survive in more sheltered environments,
Okay.
like underground or in the depth of potential oceans.
Right.
These flares definitely complicate the picture of habitability on Proxima b.
Yeah.
Yeah.
It's amazing to think about life finding a way, even in those extreme conditions.
Yeah.
Here on Earth, we have like extremophiles
Right.
that thrive in places we thought were impossible, volcanic vents, the deep ocean, even, frozen wastelands. So who's to say what's possible on a planet like Proxima b?
Exactly. Life is incredibly resilient and adaptable.
Right.
We've only just scratched the surface of understanding its true potential.
Yeah.
And that's why Proxima b is so fascinating. It challenges our assumptions about what a habitable planet looks like and where we might find life beyond Earth.
Okay, but here's another thought. We were talking about Proxima b's dense CO2-rich atmosphere earlier.
Yes.
Could that thick air actually end up making things worse? Like trapping heat from the flares like a giant oven?
It's a definite possibility.
Really?
While a dense atmosphere can provide some protection from radiation,
Okay.
it can also trap heat, leading to a runaway greenhouse effect. Think of Venus in our own solar system. It has a thick atmosphere composed mostly of carbon dioxide, and surface temperatures are hot enough to melt lead.
Okay, so we've got potential water vapor, a super dense atmosphere that could be both a blessing and a curse, and a star that likes to throw super flares. What does this all mean for our search for life on Proxima b? Is it a lost cause?
So it sounds like Proxima b is, well, a bit of a wild card.
Yeah, you could say that.
It's got, like, some promising features for life, but also some major challenges.
Definitely a planet of extremes.
Right.
And that makes it, well, a fascinating case study for astrobiologists. Even if we don't find life there,
Right.
it helps us, refine our understanding of the conditions needed for life as we know it,
Right?
and maybe even life as we don't know it, to exist elsewhere in the universe.
It's like we're trying to piece together a puzzle, but with half the pieces missing, and the picture on the box is, like, totally faded.
Uh-huh. Yeah, I get that.
Yeah.
But that's part of the thrill, right? What are we learning from JWST's observations that could help us solve this cosmic mystery?
Well, one of the most exciting things about JWST is its ability to analyze the composition of exoplanet atmospheres
Okay.
in, well, unprecedented detail.
Right.
By studying the light that passes through Proxima b's atmosphere, we can look for specific signatures or fingerprints of different molecules.
Okay.
This will give us a much clearer picture of what's really happening in that thick air and whether those super flares are actively stripping it away.
So we're not just limited to seeing water vapor anymore. We can detect other molecules that might, like, hint at life, or at least the conditions for life on Proxima b.
Exactly.
No.
And even if we don't find those smoking gun biosignatures right away, every bit of data we gather brings us closer to understanding the big picture of planetary evolution and habitability.
Right.
Not just for Proxima b, but for countless other exoplanets out there.
It really puts things into perspective, doesn't it? Thinking about those other worlds, some maybe similar to Proxima b, others completely different, all orbiting distant stars.
It's mind-boggling, isn't it?
Yeah, it is
Yeah.
a little bit humbling, too.
It really is.
Who knows? Maybe someday soon we'll be having this same conversation about another exoplanet.
Yeah.
But instead of maybe life exists, it'll be we found life.
Yeah, wouldn't that be something?
And it would be incredible. But until then, it sounds like we have a lot to learn from our nearest exoplanet neighbor. Thanks for taking this deep dive with us today. It's been it's been enlightening, to say the least.
My pleasure. Always happy to talk about the wonders of the cosmos.
And there are many. Thanks for listening, everybody. We'll catch you on the next deep dive.